Welcome to the rocket profile of New Glenn, Blue Origin's first planned orbital rocket. With a planned first launch in 2020, New Glenn may be the first rocket to launch with a methane and oxygen first stage, depending on when United Launch Alliance first tests its Vulcan rocket. Whether it is Vulcan or New Glenn, however, the first methane and oxygen engines to launch a rocket will be Blue Origin's BE-4s, since both rockets use the same engines. New Glenn has 7 BE-4s on its first stage, each producing around 2,625 kilonewtons of vacuum thrust. The specific impulse of the engines is unknown, but it is at least 338 seconds in vacuum, and no more than 363 seconds for the sea-level engines based on its stated chamber pressure. The burn time is unknown, but probably close to 3 minutes. The first stage is designed to land on a platform, some sort of barge or ship at sea, much like the Falcon 9 first stage. It is much heavier than a Falcon 9 core, but Blue Origin has been doing its own versions of SpaceX's Grasshopper test using its New Shepard rocket on suborbital hops with substantial success. The actual ability to reuse something like a Falcon 9 first stage or a New Glenn first stage, and the cost efficiency of doing so, is yet to be determined. The second stage of New Glenn is a vacuum version of the BE-4, the BE-4U. It will provide a thrust of at least 2,827 kilonewtons in vacuum with a specific impulse of around 364 seconds. Assuming it has the same chamber pressure as the surface engines, the upper limit on its specific impulse is around 379 seconds with extremely high reaction efficiency, nozzle efficiency, and a 110 nozzle expansion ratio. The version of New Glenn you see here is the 2-stage version meant for maximum payload to low Earth orbit, which is no less than 46 tons based on the lower estimates for the ISPs, and probably no more than 60 tons. There is an optional 3rd stage for high transfers though, using the vacuum version of the BE-3 engine used in New Shepard. This is a hydrogen and oxygen engine with at least 460 kilonewtons of thrust and a vacuum-specific impulse in the neighborhood of 453 seconds. For lunar transfers, the 3rd stage could push over 20 tons to the moon, probably not too much more than 20 tons, and that is because as it is burdened more, it would have to use more and more of its own fuel in order to complete orbit, and that would lead to diminishing returns. One of the benefits of the New Glenn is that it can carry physically larger payloads than the Falcon Heavy is capable of, but not quite as large as the ones that SLS can manage. With that, thank you for watching this rocket profile of the New Glenn.